Okay, so we have for number 1 in the second part of the test 1 review, we have the linear functions y is equal to 4x plus 3, y is equal to 0 as well, and we have the activity to occur between x is equal to 0 and x is equal to 3. Now, if we're looking for the area, if you notice, okay, between x equals 0 and x equals 3, y equals 4x plus 3 is going to be continuously above the x-axis, y is equal to 0. And now for the determination of the area. Okay, so we have for the activity. Okay, so we're going from x is equal to 0 to x is equal to 3. Again, we have the upper function minus the lower. So you're just looking at, in essence, integrating over 4x plus 3 dx. And so we have for the area, upon taking the antiderivatives, okay, so we're going to have 2x squared plus 3x as x goes from 0 to 3. And once again, everything is going to be running upon the upper limit. So we have 3 squared is 9 times 2 is 18. 3 times 3 is going to be 9. 18 plus 9 is going to be at 27. So we have for the area of this four-sided figure, we're going to end up with 27 square units. All right. Now, in looking at what we have for the determination of the volume generated about the x-axis, okay, and in this particular case, now we can return to using the method of disks. So just taking what we have here. So we have for the radius, again, this is going to be at 4x plus 3. And again, looking at the method of disks. Okay, so for the volume generated about the x-axis. So I'm going from x is equal to 0 to x is equal to 3. And we have pi times the square of 4x plus 3. And squaring out 4x plus 3. So we have 16x squared. And we have plus 24x plus 9 dx. And for v of x, okay, so if I take the antiderivatives, okay, so I have 16 thirds pi x cubed. And I've already got pi factored out, so I have, in this case, I have pi. And for the antiderivative of 16x squared, so I have 16 thirds x cubed. And I have plus 12x squared. And I have plus 9x. Again, so we have as x goes from 0 to 3. And so for what we're going to have in this particular case, all right, is that, okay, so we're going to have in this one, okay, so for the total volume generated about the x-axis, okay, this will end up at 299 pi cubic units. Okay, and a little correction here, not 299, 279. There we go, 279 pi cubic units. All right, now in the case of what we have regarding generating the solid about the y-axis. Okay, so we're back to our quadrilateral figure. and just taking what we have here. Okay, so we're looking at generating the solid about the y-axis. So we have for the projected radius. Okay, so we have P of x is equal to x. And for the height, again, we have h of x is going to be equal to 4x plus 3. And for the volume of the solid generated about the y-axis, again, we can revert to the method of shells. Again, so we're looking at integrating with respect to x. So again, I'm going from x is equal to 0 to x is equal to 3. And I got 2 pi. P of x is going to be at x. And h of x, again, we have at 4x plus 3. And it's just multiplying together. So I have 8 pi x squared plus 6 pi x dx. And for taking the antiderivatives, so I have 8/3 pi x cubed plus 3 pi x squared as x goes from 0 to 3. And so just taking what we have all together. And for this total, I knew the 99 was going to come somewhere, but it wasn't going to be in 299, but just 99 pi itself. And so that would be the volume of the solid generated about the y-axis. And you would want to go with something like the method of shells, because what would happen, I'm just going to throw this in right quickly, is that for the quadrilateral section, okay, now we have for y is equal to 4x plus 3. Now if I were to take this and integrate with respect to the y variable, what would happen here is that I would have for x, I would end up with 1/4 of y minus 3/4. And what would occur in this particular case now, if you notice, you have for this particular section, let's go ahead and identify by the coordinates. So I have 0, 3, the origin, again I have 3, 0, and I have 315. I'm just going to mention, okay, now for the lower portion, for that which is beneath 0, 3, okay, so this particular part, I'll be looking at the discs, and above here, I'll be looking at the method of washers. And so if I were to take the washers, and I would be integrating with respect to the variable y. So for the volume generated about the y-axis, what would happen here is that, okay, for what I have going from y is equal to 0 to y is equal to 3, I'd be looking at the radius. Okay, so the method of discs. So I'd be looking at pi and the radius. You have 3 minus 0. So pi times quantity of 3 squared and I'm going to use the washers, but the discs part, okay, have lower region. So you have pi times the square of 3. This will be dy. And we have, in the case of the washers, so we'll be going from y is equal to 3 to y is equal to 15. And what would happen here is that the outside radius will be corresponding to x is equal to 3. And for the inside radius, you have 1/4 y minus 3/4 quantity squared And I would very much rather be using the method of disks in this particular case. And if you were to add up these sections, your total is still going to come out to 99 pi cubic units. Okay, same result, just as accurate, but a whole lot more work involved.